First, we have 5 different unique elements, which is 5, 1, 2, 3, 4, and the frequency is represented at count at key, which is 4, 3, 3, 2, 1. And then we create a list of buckets, which have a lot of buckets, and then we use the counter at key as our indices, which is index 0, 1, 2, 3, 4, 5, blah, 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 until the length of them, which is 13 in this case. So how many buckets we have? We have the length of them plus 1 bucket, which is 14 in this case. And we just put key inside the bucket. We name them num, and then we use a for loop the key. We add key into the bucket. First, we add key 1 into the bucket 3, and then we add key 2 into bucket 3, and then we add key 3 into the bucket 2, and then we add key 4 into the bucket 1, and then we add key 5 in the bucket 4. And then we create a new empty list flattened to reverse the result. We use a for loop, the loop from length of buckets minus 1, which is 13, until -1, which will end at index 0. First, we put key 5 from the bucket 4 into the flattened list, and then we put the 1, 2 from the bucket 3 into the flattened list. It is in order because we use a for loop for them in the buckets at I. And then we put key 3 from the bucket 2 into the flattened list, and then we put the key 4 from the bucket 1 into the flattened list, and then let's use a for loop to loop from the first element to k-1 element. So this is top k most frequency element. We just return top as our result. First, we create a counter in the collections module, which is a dictionary-like object. It takes an iterable names list as our input and then returns a dictionary-like object with the counters of each element in the iterable. Creating a counter object takes all of n time. Well, n is the number of the elements in the input list. This is because it requires us to iterating over the entire input list to count the occurrences of each element, and it takes all of n space since it needs to store the counts of each element in the input list. So specifically, the space required by the counter object is proportional to the number of distinct elements in the input list. To store the element with same frequency, we create a list of bucket, which is a list of lengths of lambs plus 1 empty list. Well, the index of each list which corresponding to the frequency of the element in the input list, and it only takes all of n time. Well, n is the number of elements in the input list. This is because it requires us to iterating over each element in the counting dictionary, which takes all of n space since it needs to store the elements from the input list in the appropriate buckets. So the space required by the list of buckets is proportional to the number of elements in the input list. We create a flattened list of elements in the input list. We sort it by descending frequency. It iterates over the list of buckets in reverse order, starting with the bucket containing the element with the highest frequency. So we just append the element from each bucket to the flattened list. So it takes all of n time. This is because it requires us to iterating over each element in the bucket list once, and it takes all of n space, since we need to store the element from the input list in the flattened list, which is proportional to the number of elements in the input list. And finally, we create a list top, which contains the first k elements of the flattened list. Then we return it as our output, which takes all of k time, since it involves selecting k elements from the flattened list. Since k is typically much smaller than n, this step has a lower time complexity than the previous steps, since we just need to store k elements from the flattened list in a new list. This is a constant amount of space. We don't depend on the size of the input list, therefore the space complexity is all of 1 space.